To determine sea level rise for a given year, look at the year of interest on the x-axis. This could either be an event date, it could be the date of construction, it could be the end of life for the structure, remember 50 years from the day it was built, or it could be the end of when your planning horizon. If you're making a plan for 20 years, it would be the end of your 20-year planning horizon. Then you go across to find the relative sea level rise on the y-axis for the curve that is relevant to your project. How to apply the curves. First, the blue shaded zone between the IPCC median and the NOAA intermediate high curve, the two lowest curves on the Unified Sea Level Rise projection, should be used for most projects, especially projects with a life expectancy of less than 50 years, meaning they will be replaced by 2070. Projects that are easy to replace, maybe it's a pipeline that is going to be replaced every 10 years, or maybe it's adaptable infrastructure. It's a seawall that you can add a cap to in order to make it higher to resist tidal flooding during this 50-year horizon. Also, it should be for projects that have limited interdependencies. If it's a piece of infrastructure that many different business sectors or property owners or even other pieces of infrastructure are connected to, then it would be considered to have high interdependency. And if it fails, all of those connected sectors and pieces of infrastructure would be at risk of failure as well. So if something is going to be only around for less than 50 years, it's easy to replace, and if it fails, it really only affects a small portion of the community, then you should be using this blue zone. To decide what actual sea level rise value you use within the blue shaded zone, you need to weigh the potential benefits versus the additional costs. So there may be a benefit to build to the full 40 inches in 2070 because you will have reduced insurance premiums. You could avoid some damage as a result of tidal flooding or maybe even storms and flooding. And if there is a failure, you're really having a reduced disruption to the community, meaning that the community around it can still function. You have to decide if those benefits are worth the additional cost it will take in order to build the infrastructure higher or to a more robust standard to handle more volume of water or resist corrosion from the salt water more effectively. If you do not need to spend, if you don't have the budget or you don't feel that the project is worthy of the additional cost, then you need to be prepared for the consequences of under-designing and acknowledge that your equipment or infrastructure may need to be replaced sooner than it was fully intended. If you have critical infrastructure that is risk intolerant, meaning that it cannot be allowed to fail, an example of this may be the nuclear power plants in Miami. It may be the wastewater treatment plants that are near the coast. It could even be a government center or government infrastructure that is essential to continuing operation of our municipalities. Or it could be infrastructure that you know will be in place longer than 50 years. This may be a railroad, it could be our canal floodgates, it could even be some of our buildings. For example, the building I'm standing in has been here longer than that. So if that's the case and you cannot adapt it or move it or replace parts of it to make it more resilient, then you need to be planning for a more conservative or higher rate of sea level rise and use the NOAA high curve.